Hey guys, welcome to Civil Engineers Adda. My name is Abhishek, kamadollishettar, MTech in Structural Engineering. So guys, in the previous episodes you have seen the discussion regarding computer aided building planning and drawing, and today we are going to see discussion on the IS code, the code which is used for the AutoCAD drawings and even the NBC, that is National Building Code as well. We are going to discuss it. Okay. So guys, you can see that this is a national code, Indian standard code for practice for architectural and building drawings. Okay, this code has been prescribed by VTU for your reference as a AutoCAD drafter. Okay, so this code is required to have a very basic knowledge of drafting. So the code is the IS, okay, Indian standard 962 1989. Now I will even provide the code in the description. You can download it from there. So just going to the next slide. So just we'll begin size of drawings. So regarding the size of drawings, first what thing they have, I have taken only the important parts of the code, since it is not very full requirement. It is required to study the code thoroughly, but in the one video completely I cannot explain everything in the code. So the main highlighted points I'm going to discuss. So in table 1 it is there, like it is the preferred sizes. Okay, you have preferred sizes of the sheets, okay, of the drawing sheets which you are considering. There are drawing sheets. Yeah, I think you have already heard of drawing sheets like A4 drawing sheets, A3, so and all other things. So there are different types. So you can see all the dimensions they have given in millimeters. Like you should know the dimension of a A0 paper. So only one thing you should understand is the sizes which you are going to use as a paper. So just observe here A0, A1, A2, A3 and A4. Okay, so there are serial wise 0, 1, 2, 3, 4. Now dimension, you can see that 874, always it is length into breadth. So whatever you are seeing, it should be always into length into width or breadth, you can say. You can see that A4 size is like, this is 200 mm, 210 mm, sorry, and this is 297, approximately you can say it as 300 mm. Okay, so it's a completely, you can say it is a 30 centimeter, one full size long scale. And here it is 21 centimeter. Okay, so this is the width of your A4 size. So as the number goes on increasing, see from A0, 1, 2, 3 and 4, as the number of order decreases, the dimension also number increases. Sorry, I'm very sorry. As the number increases, okay, you can see 0, 1, 2, 3 and 4, the numbers are getting increased. Based on that, the dimension goes on decreasing. Okay, the dimension also decreases. See, you can see the dimension is decreasing. As the numbers are increasing, the dimension is decreasing. So one thing you can observe here. And one more second table is table number 2. See, one more thing you should understand is what is this clause 3.2. So clause 3.2 is like there will be first section, in that the subheading 1.2, so that itself we call it as a clause. Okay, we call it as clause 1.2. like first main is the main heading. Suppose let's say sizes is the main heading. In that you are getting 1.2 as preferred size. Okay, preferred size. So this is a subheading, but we will mention it as clause 1.2. Here table number 2. Special elongated sizes. Okay, this is according to clause 3.3. These are some special elongated dimensions. They have specific uses. You just need to know what all these things are. So let's go into the next thing. Layout of drawings. So you know what is the layout. Layout is the place, like it is a area of drawing where you have to picturize your drawing. So this is the layout. Okay, what type of layout it is. So you can see A0 is A0 into 2, A0 into 3, there are different sizes. So there is an asterisk here. For practical reasons, the use of these sizes is not advisable. So it is just what you can say, it is just a paper. Okay, it's a long paper. Sometimes you can see even the plants in a very long paper that will not fit into the normal printing machines. You require a jumbo Xerox, or you require a big Xerox. Okay, so A1 into 3, A4, there are 4 combinations of A4. See here, there are 4 combinations of A4 size paper also. So one thing you should remember. Okay, so apart from that, sheet. So just see here, sheet 4 of 12. Like whenever you want to mention, suppose there are 12 sheets in your drawing, so the designation, the naming should be given. It should not be given simply as 1, 2, 3. It should be given completely with an information stating sheet 4 of 12. Like it should inform that there are 12 sheets. In that we are looking into the 4th sheet. Fine. Next very important thing is scales. Very important. It's very important. Scale is a factor. Scale. So scale. So you can see that scales according to IS 10713/1983. Okay, on the technical drawings, here you can see on the technical drawings, the following scales can be recommended scales. Means they have recommended you use of the scales, but it depends on your scope of work. So first important category is enlargement scales. First important is enlargement scales. What do you mean by enlarging the scale? Enlarging the scale means, suppose I do an object of, suppose let me do an object like this. Suppose if this is the actual dimension, if I increase the scale, if I increase or if I enlarge the scale, I will get the same figure converted into this shape. You all might have observed this while doing the zooming in and zooming out of a snip. Okay, so this is an enlargement scale. So this is an enlargement scale. So for scales are 50:1, 20:1, 10:1, 5:1, 2:1, which means it, see, I'm just giving you the value here. It means to tell you that 50 parts, so one part of the dimension, one part of dimension actual length, one part of actual length is equal to 50 times of the length on drawing sheet, on the drawing sheet. So remember, so got it? No. So what is the meaning? One part of this length is equal to 50 times, means you are enlarging the scale, you are enhancing the scale. That is what I mean. So that is the thing. So you can give a definition like, you can say size in map, map size on map on drawing sheet, size on drawing sheet divided by the actual size. Okay, scale definition, you can give scale definition as size on drawing sheet, size on drawing, let's say only drawing, size on drawing to the actual size, is the basic you can say as a definition or as a formula. Next, second one is full size. Full size means whatever you see, you represent. Suppose if you are seeing a 30 centimeter scale, and that same 30 centimeter you are drawing in your drawing sheet, so then you can say that scale is 1:1, means there is no change in the map in the drawing sheet. There is no change in the dimension in drawing sheet as well as the actual sheet. So that is why we say such scales as full scale. Okay, full size scale, 1:1. Remember, 1:1 is a full size scale. And the last one is, third one is reduction scales. So in reduction scales, that is the third one. So here we are reducing the entire length or whatever dimension we are considering, we are reducing. So only the name is given as reduction scales. Okay. So just let me give you an example. Suppose if there is a length, okay, if there is a length of distance between Hubli to Dharwad is a place in Karnataka, it is having 20 kilometer difference. Okay, 20 kilometer difference. So suppose, how can you draw a 20 kilometer line on a drawing sheet? Suppose we are using a let's say we are using an A3 sheet. Okay, A3 sheet, and if you want to draw it on this sheet, whether it is possible to draw? No, considerably you have to reduce the length, so you have to take scale. So usually we did this in graph papers, we usually reduce the scales there, but we actually did not know the purpose. Like some people know it, but some people need to understand reduction scale 1:2. See, such scales, when you see such scales like 1:2, 1:5, 1:10, 20, 50, 1:100, 1:200, so on. Okay, so which means the entire length of this 20 kilometers, it will be converted to just depending on your scale, whatever you choose. Suppose if you are selecting 20 kilometers, so let it is 20,000 meters, so I will select 1:1000 scale. Suppose if I select scale as 1:1000, so what you need to do, just simply divide this entire number by 1000. 3 zeros gone, 3 zeros gone, so 20 meters. Okay, 1000 millimeters will give you 1 meters. Okay, so we can say that this is 20 mm of line you have to draw on the map, so the entire thing is reduced. So this is the reduction of scale. I hope you understood. The entire the bigger lens will be converted into the smaller lens to fit into the drawing sheet. Okay, to fit into the drawing sheets. Okay, fine. Next, I hope you understood. So next, okay, in case of the line work, you can see all lines shall be dense, they should be clean and black. Okay, to produce good prints, that is there. And the types of lines, there are different lines that you should consider. That all those things I'll show in table number 5. It's given here in table number 5. I will show that. Thickness of lines, the ratio of the thickness to thin line should not be less than 2:1. In the sense, see here, 2:1. Suppose if you're drawing a normal line, your thick line, so when you consider the ratio of the thickness of the both lines, it should not be less than, the ratio should not be less than 2:1, or it should not be less than 2, which means that your thicker line needs to be, it should be double the thickness of your normal line. Fine, so it should be double the thickness of your normal line. Fine. So next, the thickness of line should be chosen according to the size of the type of the drawing. So there are different thicknesses of lines that you can use, that you will be having in the software. That we can see. So just see the table number 5, which I just explained to you in the previous slide. So this is a continuous thick line. So you can see in the first part here, it's a continuous thick line. Where it is used, visible outlines. See, visible outlines and visible edges, like in drawing, where all you can see in a plan view, in a section view, in a elevation, the lines which are visible. See, when you want to see a column, footing of the footing and a column, foundation isolated footing, so you can see all these edges. You can see all these edges, they should be dark, which should be thick. So that is the meaning of this continuous thick lines, visible edges. So next one is continuous thin. Where should be your thin line? Imaginary lines of intersection, dimension lines. So if you are having a dimension line like this, very small dimension, suppose we can have 2000 mm. So these lines, so I'm just giving you like these lines, they should be very thin. Dimension lines. Projection lines, see, projection, I'm just giving you a projection like this. Suppose if I take a projection like this, these lines should be it should be thin lines. So all the work you have to do, all the work is done by the AutoCAD software. You need not worry. You need to select. You should know what is hidden line, what is a continuous line. For all that reason, we are doing it. Leader lines. A leader in the sense I told you. So what is a leader? It will give you the arrow mark with a line explaining what is this. Is a column. Suppose 200 into 300. So this is a leader. Next, hatching. Hatching is inside, like the portion which we hatch. Suppose this is a wall, so we do hatching in this way. So we'll do for that. All those things you need short lines, like continuous thin lines, short center lines. So center lines. So this is the center portion of the entire figure. So that needs to be your thin line. Continuous thin freehand, limits of partial, this is not much needed. Dashed line. Okay, I'll give you the code entirely, you can go through that, but whatever is restricted to the important things, I'm going to stick on to that. Dashed thick, hidden outlines. See, you can see that it's a hidden outlines here. You can have this as a dot lines, like you can have this as a thick one, dashed thick and dashed thin. So both of them you can see. One more thing, chain thin. Chain, you can see just there is a dot here. After a single dash, after a single strike of line, you have a small dash or line here, small dash line. That is a chain line. Like you are having chain, like normal chain doing surveying. You can see there's a small link. Again, there's a chain. Center lines, usually center lines. We provide this for center lines. The symbol for center line is sometimes like this, CL. Center line is provided in this way. And cutting planes. See, the cutting planes or sections which you need to consider. Suppose I want to cut this wall. Suppose I want to cut this plan. So I need to have a cutting edges. I want to cut up till here. Then I want to go straight like this and then cut. So these all things, this type of line is used, which is that thin, thick at the ends and changes the direction. And chain thick line, I have told you already. Chain thin and chain thick. Chain with the double dash. See here, you are having double dashes here. These are chain with double dashed lines. These are used for adjacent parts, alternative and extreme positions of movable parts. So when you make use of this is when there is a complex drawing, we make use of that, or else we can have the important things which I have told you. Hope you are understanding. Next part is dimensioning. Okay, next part is dimensioning. So while providing the dimensions, the termination, see how you will give the termination of the dimensions. There's an end, there's a start, end, and there's a dash here. So what should be the angle here? It should be the 45 degree. The line should be drawn at a 45 degree clockwise. So clockwise in the sense clockwise 45 degrees. So all those things are required actually. Some very important things I'm going to tell you. Next figure we'll see the very important things in a diagram. We'll understand in a diagram. See, you can see that it is a parallel dimensioning. Parallel in the sense all the dimensions are parallel to each other. This line is parallel to this line, and this 3490 dimension line is parallel to 4480 line. Okay, fine. Superimposed running. See, superimposed running in the sense one side you will start, or your origin will start, and you will go on giving the dimensions wherever the edges comes. So this is one dimension, and next dimension here. So actually it is 750 from here, again it is 990 from here, but we don't write this, we don't mark this, we only take it from the beginning of the previous dimension point. That is known as a superimposed. Like you're imposing, like this is one dimension, there is another dimension, but you are not writing this line directly, you're taking from here. It is superimposing dimensioning system. Okay, I hope you understood. Now what I'm going to tell you is superimposed running dimension. Superimposed and running dimension. You can see projection lines. See, these are the projection lines which I told you. Like, you will drop it from the actual drawing. You'll leave a offset. There is a gap here. Continuously you can't take it. Otherwise there will not be any bifurcation. There is a gap here. Small gap should be there. That gap is called as offset. That gap is called as offset. Okay, while doing it in software, while doing it, I'll just tell you there once again, but here you can see. So this is a dimension line combined, a superimposed running dimension. See, again it is superimposed here. What is the difference between the two thing here? It is that the here it was starting from 0, like here also it's starting from 0 itself, but there's a termination. You can see there's a continuously termination dimension line arrowhead. Fine. So almost there is not there is no such difference here. So next one is the graphical symbols. Graphical symbols. So while dimensioning, you can use the graphical symbols, like see, for doors and windows, how you will write that in the drawing. For window, what you will designate, and the types of symbols that we usually use, like for ventilations, for doors we write D. All those things we can see. So you can see that there are different window types that you can draw in your AutoCAD drawing while planning. There are different types. Vertical center hung, like when vertical it is hung, so the windows will be opening. Bottom hung. Okay, so there are different types. You can select any one from your this one, but we will go into details when we draw. Graphical symbols, other graphical symbols we can see revolving. You just remember, this is one important. Revolving doors. So for revolving doors, what we can say, like this, revolving windows, or you can say these are the doors. Actually these are the doors you can have here. This is a door system. So normally we do this thing, and sometimes we go for this also, sometimes this also we do. But depending on your sliding windows, here you can have a sliding window. There's an arrow here. Revolving door. And you can see side hung door is like your normal old type of conventional doors. There are two panels here, and there will be two panels, like they will close up till here, and this will also close here. So it's a center hung, folding double leaf. There are different types of doors that you can consider. See, a rolling shutter. Usually in shops, during in the shops, commercial shops, you can see that's a rolling shutter. It will be a drum there, it will be rolling. And some other doors will be having a projected hinges also. So all those things are there. Depending on your requirement, it can use. So this is a continuation again. There are different type line, different types. You can see the initial letters. Combined drain lengths. The line existing of medium length dash lines, dotted chain lines. It's a chain line. It's just, you can usually give it for a center line. Okay, large chain line. Fine, all those things are done. Next thing is the direction of flow of fluid. So always we should mention it as a triangle. Okay, so there's a triangle. Rise and direction, rise and fall, you can mention it by the arrow symbol. Village surveyed, open village wall, everything. So small, some small things. I cannot explain everything in detail here. We can go through the code book, but main thing I'm doing here. Graphical symbols, again you can have the different things. Symbols, see, just for rain water well, you can have the symbol in this way. Like all these symbols, they will directly use in the drawing. They will not give you an idea. Only thing is you should know what all those symbols mean. See, for air, there's a letter. Okay, there's a specific letter A. Drainage D. For electricity E. For fire service, if it is F, and R, refrigeration. So all those things you can still go through that. Inspection, manhole cleaning. So for that, the representation is very simple. So fine, we have abbreviations now. Yeah, abbreviations are the short forms of the words that can be used while drawing. So you can see for aggregate, we completely don't write it aggregate. You can write it as AGG, simply as HGG. Okay. So again, there are a lot of things. See, for beam or I section, we usually write it as I. Okay, I section. So again, lot of things are there to discuss. See, for cement concrete, very important things I am going to only discuss here. For cement, you can write as CT. Don't CT. For cement, you can abbreviate as CT, and for cement concrete, you can abbreviate as capital C and capital C. For centimeter, you know, for center of gravity, CG. For center line. So this table is important because you will have a lot of uh, abbreviations to be used in your life, engineering life. Centimeter, center line, center of gravity, center to center. See, we will mention always this. We will use this many thousands of lakhs times. Center to center. You can write like this, or C to C. Again, it will be lengthy. This is better, I think. Center to center. Center to center. Circular pitch column. See, for column, the shortcut is COL. For column, the shortcut is COL. You need not write complete word. For concrete, so just remember, for concrete, the shortcut is CONC. CON, capital C is the concrete symbol. And for corrugated sheets and some other things like cubic meter. See, cubic meters. Cubic, for cubic meters, it is meter cube, like in this way. So all those things are there that you can see. Next one is hatching. So for hatching portion, you can see for different works, we can have a different hatches. See, for glass, we are having a very glazed thing. For brick, we are having this thing. So completely, if you see the code, you will understand. While drawing, at least you will get to know all those things. So concrete, see, for concrete, actually a little bit it is not clear here, but still I'll try to give you the best knowledge out of it. So for concrete, you have to small triangles, solid filled triangles here, like it's a mixture, solid filled triangle portions, and then you have a dots, like, yeah, fine. Now earth is in this way. For bricks, it like wood, it is in this way. So stories, regarding stories, you have to have an idea of what is a story and what is the difference between a level. Okay, so story means a space. There's a definition here. A story means a space between two consecutive levels. See here, it's a story is a space. This story is a space. There is a level here. There is a level here. Story is the space between the two levels. Okay, so very beautifully he has given the definition. Bounded by the physical limits like floors, ceiling, including these limits. The concepts of story and level are complementary, like they are little bit, like you can say, an opposite to each other, like they can have a thing, but the one should not be confused with the other, like they are complement, like you can have a same thing. So zero designates the space which is situated immediately below the level. So let's directly go into the figure number 18. You can see that this is a story 0. So this is a story 0, 1, 2, 3, 0, 1, 2, 3, 4, 5 and 6. Last story. And figure 19, you can see that this is some level here, level 2, level 3, level 4. In this way, it's going indication of the level, like how you indicate that. First 18 figure 18 and 19 indicates you the how to indicate the stories and floors numbering. Now figure 20, designation of parts of a story. Designation of a parts of a story, like story 3, you will have a story 3, you can designate as A block, B block and C block. Fine. And the 21st figure, floor numbering, you can have a floor numbering. This is very important. This is very important from understanding point of view. So you can see here, this is story 0, first story. Still then you will be in the level 1. Still then you will be in the level 1. So you can see here, this is a level 1, 0, 1, 2, 3, up till 6 story. 6 story. So 6 stories in the sense floors, number of floors are 5. Like you can have the available space for your works. So this entire thing will be situated below the ground. Actually this will be, it will be situated in the below the ground. So this is your 0th floor, like ground floor, first floor, second, third, fourth and fifth floor. Level is 1. Like you will start always with 1. There is no level 0 actually. You will always start with the level 1, level 2, 3, 4, 5, 6. So story also will start from 0, but it will start from even from the substructure. Like it will include the footing and foundation, column. So from there we can start considering, like from this level we start. Next one, designation. Column. So how will you use your designate, like how will you indicate in a drawing? Suppose if there is a column, so you have to name it as only C, slab S, wall W, beam. So this is an elevation, guys. So in elevation you can see that they have indicated the slab number 101, 102, 10201. Like it will indicate the second floor. This is the second floor, third floor and fourth floor. Okay, so first floor, this is the first, this is the second floor, this is the third floor and this is the fourth floor. Okay, so you can see the columns which I am just doing it with the dots here, just continuous dots. These are the columns. Okay, these are the column. Yeah, now next one is beam. You can see the beams, like they are in the portion, like they have given the naming of the beam as B401. So these are the beam and slab. Actually beam and slab will be together, like this is the beam portion. You can see beam portion is here and slab will be in the plan. You can see the slab very clearly. I hope that is fine. Okay, that all things you will learn while doing the AutoCAD drawings. So designation code, you should write always in the capital letters. Always you should write in the capital letters. House, room, window, door, fence, cutoff, whatever is there, you have to write it in the capital letter. And you can even use the abbreviation like HR and all those things. So coloring, so you can see coloring the plan. So you can see how for building plan, I'm talking mainly on building. For there are two types, site plan and building plan. For building plan, existing work should be given in black, die line print, and blueprint it is white. Blueprint, it will be, blueprint is just a print in the just a final, it's not a full final, it's a very computer drawing. Drainage and sewage work will be red dotted. Proposed work, like what you are proposing will be in red color. Okay, it will not be in the already existing plans will be in black. Whatever you are proposing, it will be in red color. Drainage and sewerage work, you can see red dotted lines. Water supply works, black dotted. See, water supply lines, like you can have water supply lines like this. So I am using red here, but actually it will be black. Open spaces, you don't have anything to mention there. So this inside plan, open spaces, no color. Here also no color. Permission building lines, it should be thick black dotted, black, thick dotted black. Existing streets are should be in green color. Future street, if any, like they should be green and dotted, future thing. So fine, I think this is the end for the, it's not an end actually, it's just a beginning for you to go through the IS 962 code. It's very important to understand the code before you actually start drawing. The National Building Code of India 2016 volume 1. Okay, so this is the volume 1 National Building Code. This code is used as a National Building Code. So what all it consists, I'm just going to give you there are two volumes actually. Just understand, there are two volumes, volume 1 and volume 2. In volume 1 you will have the following things like integrated approach, prerequisite for applying provisional code, definitions of various terms, fire and life safety, building materials. So if I just click on that, you'll get an idea of what will be there inside here. So you can see materials. Just click on the materials, what type of materials you need to use, which type of code it is subjected to, all those standards, very very detailed. Just see the book here, it's like 1226 pages. So it will give you all the like which all code you need to refer for the different specimens, all those. Just see the codes, how many codes are there, hardly how many you know. So just understand the level of depth in which this code specifies. And it actually, you should it's like a Bhagavad Gita for civil engineers, and you should read it in your lifetime. So guys, I think you enjoyed the video. So I tried to convince you the code that is 962 and NBC. So please don't forget to subscribe my channel. I get really motivated if you do so. And please share this video to your friends, and have a good day.